Hello everyone, welcome back to Zenith Integral Academy. So today we are going to continue from where we stopped, and that is block diagram and transfer function. So here we are looking at case 2 for a system that is connected in what? In parallel, control system connected in parallel, and we have this. Now we have our RS, just like we said, that it is the input signal that is feeding these three different elements of G1, G2, G3, accompanied by a forward path element. Each of it is a forward path element, and we have the circle plus plus plus. At the same time, we have our output signal of what? Of CS. So we want to find our transfer function, and our transfer function is ratio of our what? Our output signal over input signal. Meaning, I want to find here now my output signal is the same thing as CS all over my input signal is the same thing as RS. So this is what I want to find. Now this RS, when you take a look at it, you can see it is serving as an input signal to this 3. So the first one, let me say RS, which should be serving as an input signal to G1, is going to give me a corresponding output signal of what? Of A. This same RS serving as an input signal for G2 will generate an output signal of what? Of B. Similarly, RS, which is serving as an input signal for G3, will generate an output signal of what? Let me call it C. So now let me now denote what A is going to give us. So A is going to be equals to, since I made us to understand in the last class that whenever you have a rectangle, we multiply. Whenever you have a circle, you add or you subtract. So for us to have A now, it's going to be G1 will multiply your what? Your RS. RS will multiply. So I'm going to be having G1 RS. So let me call this my equation 1. Similarly, for me to have my B, it will be equals to G2 what? G2 RS, call this 2. And C will be G3 what? RS, call this 3. Now, addition of A plus of B and plus of C is going to give me what? It generates an output signal of what? CS. So I can say CS is equals to plus of A plus of B and that of what? Of my C. So I'm going to be having CS to be equals to what is my A? G1 RS plus what is my B? That is G2 RS plus what is my C? And that is G3 RS. Now, we can say my CS to be equal to, there is something that is common, which is my RS, so I factorize. So I'm going to have RS into bracket G1 plus G2 plus G3. And what I want to find output signal over C, which is CS all over RS. So I can divide through by RS, divide through by RS, this can of this. So I can say my output signal now all over input signal now is equals to G1 plus G2 plus G3. So if I'm giving a block diagram of this and I'm asked to find transfer function, so this is what I am going to have when they're connected in what? In parallel. So let's look at other ones that we have, other systems. Now we have our case 3, which is a control system with unit feedback loop elements. You can see our RS here is having a forward part. This is forward part. Now we now have a new form of a corresponding feedback element. And when you take a look at this feedback element, it is coming from where? It is coming from the output signal CS. So meaning if I should trace this thing where it is coming from, the corresponding feedback is coming from the output. So here I'm going to be having what we call CS because it is coming from the output signal CS. And now I want to find the transfer function, which is ratio over what? Output signal over input signal, which is the same thing as my CS all over my what? My RS is what I want to find. Now you can say I'm having a circle plus and minus. Input signal of RS with negative of my CS is going to generate an output signal of what? Of A. Let me call it A. A will multiply my what? My G1 to give us an output signal of what? Of CS. So that's what we are going to be what? To be having. And mind you, this method I'm applying is the analytical method. We have another method of analyzing block diagram. There are two methods of analyzing block diagram. The first is what? Is our analytical method, which is one I'm using now. And the second one I'm going to be discussing later in this class is using row reduction method. Row reduction method. Please let's take note. So let's quickly solve this question, then I'm going to be analyzing the other two later. So for me to have my A is going to be equals to plus of RS, then negative of CS, my A. If A should multiply G1, is going to generate an output signal of CS. So I can say my CS is equals to G1A, and that's the same thing as G1 into bracket RS minus CS. So I have my CS to be equals to, if G1 should multiply this, I'm going to be having G1 RS minus G1 CS. So you collect similar terms. If minus G1 CS should come here, I'm going to be having CS plus G1 CS to be equals to G1 RX. And when you factorize out, I will have CS into bracket 1 plus G1 is equals to G1 RS. So I can easily say from here now, if you should divide through by your RS, this take care of this. So I can say my CS all over my RS is equals to G1. Then you can bring this 1 plus all down. So I'm going to be having 1 plus G1. So this is going to be my corresponding transfer function whenever you have this kind of system. Please take note, this is one of the simple systems that we can have, a control system with unit feedback loop elements. You have this kind of thing whenever you are solving a complex block diagram and you happen to come across something like this, you can automatically reduce this and just input this inside the block diagram. That method is what we call row reduction method. So we are going to be discussing it later. So let's look at other cases of block diagram and transfer function that we have. Now let's take a look at this case 4, which is a control system with feedback loop elements. Now the feedback loop element here is your what? Is your H1, as we can see from the block diagram. Now when you take a look at this this block diagram, it's also similar to the one that we just did. Now that one is just a control system with unit elements, with unit feedback elements. But here we're having a control system with feedback loop elements. So now, and which is H1. Now look at H1, look at the feedback. It's also coming from what? CS. So if CS should multiply this this H1, I'm going to be having an output signal of H1 CS, because look at the arrow, look at the direction, it is coming from CS. And since this is a what? Is a rectangle, I told you we multiply, so it's going to give me this. So now plus of what? Of my input signal RS, negative of my H1 CS is going to generate a corresponding output element of A. And if A should multiply my what? My G1, I'm going to be having an output signal of what? Of CS. So that's what I'm going to be now. So I can just easily say that my A is equals to plus of RS, then negative of H1 CS. And if A should now multiply G1, I'm going to be having what? My output signal CS. So I can say my CS is equals to G1A, and that's the same thing as G1 into bracket RS minus H1 CS. So my CS will give me G1 RS minus G1 H1 CS. So you collect similar terms. There is CS here, there is CS here. So when you bring your CS to the side, it becomes positive. So I'm going to be having CS plus G1 H1 CS to be equals to G1 RS. So when you factorize, I have CS into bracket 1 plus G1 H1 to be equals to G1 RS. So your transfer function now, which is CX, bring your RS down, cross multiply, will give us G1 all over, bring this one down, 1 plus G1 H1. So this is what I'm going to be having as my transfer function. Please, let's take note of what? Of this very, because whenever we have some complex one which we are going to now, we are just going to substitute this value. You have a given transfer function like this, we can easily reduce it to something like this. So we call that one method of what? Row reduction. So in a question, we can use row reduction and analytical method at the same time, and that's what I'm going to be doing in my next video. Please make sure you subscribe to my channel, and thank you for following me through. I love you all.